Hello, my name is Moustafa Mahran.
And I'm Ammar Yasser. We're here to give you like an orientation or introduction to our project as an overview. So the idea of our project arises from the urge of helping people with disabilities in overcoming and performing their life actions. And because all of us are aware with how hard it is for blind people, especially in Egypt, to walk around, to perform their daily routines, and it's even harder for them because they have to frequently ask for help, which leaves them feeling helpless and frustrated. We decided that we have a chance to help them and impact them through this project. So putting this motivation in mind, we decided to give them a chance to be self-dependent. Thus, the name of our project is called The Third Eye.
So why it's called the third eye? Because it's the first step in what we hope, to build a complete guide system for blind people in order to help them to detect obstacles on their own without any external help. Thus, with all the capability that we have, we decided to choose ultrasonic sensors to detect such objects, to alert the person when to move and where to stop.
My name is Mariam Korashi, and I'm going to provide you with a brief introduction to the components that we've used in our project. In order to implement the project that my colleagues have talked about, we used, most importantly, the Altera board. The Altera DE2 provides a platform for us to integrate different functions and different functionalities that provides us if we connect it to the right software on our laptop. What we have used from the board itself is the LED display screens to provide the digits we have here, and its input-output pins to connect it with other components as well.
Okay, we have also used an ultrasonic sensor. This ultrasonic sensor is connected to the Altera board using input-output pins. The Altera sensor is using the echo mechanism. It sends an echo and waits for the response to calculate the distance. As you can see here, if I move my hand away from it and near it, the display on the LEDs change with respect to distance in centimeters. Okay, we also use the speaker, which produces the sound at a distance 100 centimeters and another distance at 20 centimeters. We also connected the speaker to the Altera board through the input-output pins and also to the voltage produced by the board. Now we are going to test our project. This is a plug that is coming near to the sensor, and it will produce a sound at 100 centimeters and a different sound at 20 centimeters.
Now I'll talk to you about the ultrasonic sensor and the procedure we used in the code to detect the distance. The ultrasonic sensor have three inputs and one output. The output is the echo, and the three inputs are the trigger and the clock and the VCC. The VCC is 5 volts, and we get it from the Altera. The input, the trigger. When the trigger is on, the ultrasonic sensor sends a wave and receives it. And receives it in 38 times 10 power negative 3 seconds, and this is the maximum with 6.4 meters. And by the 38 and times 10 power negative 3 seconds, we can get the distance using the sound of wave. It's the distance going and backing. If we divide it by 2 and multiply it by the sound of wave, we can get the distance. And my friend Mirette will talk about how we generating the sound in the video.
This is Mirette Ehab. Now I'm going to explain how we use the distance that Amer got to us to generate the sound. First of all, I have to let you know that we use 2 different sounds for each range. So from distance 0 from the sensor until 20 centimeters, it uses a specific sound, and from 20 centimeters until 100 centimeters, it uses a different sound. This helps the blind person know the difference between the locations and positions of the objects ahead of him. What we use is a 16-bit counter. It counts from 0 until 65535, and we use a clock of frequency 25 megahertz. The idea is that the clock, every 2 times 10 power negative 8 seconds, the counter is decremented until it reaches 0. When it reaches 0, the result the timer got, or the program gets ahead, it's put in an if condition. If the distance is included in the range that we want, it produces the sound, and the sound is toggled, which makes it go from 0 to 1. If it's not, then nothing new happens. So the highest bit toggles at the frequency of 381 Hz. Yes, thank you. So to conclude, now the echo, we use the echo to get the distance, and from the distance we decide if the sound should be generated or not. In a future phase, this sound will be close to the ear of the blind person, and this should help him detect obstacles and know where to go, and differentiate between the locations and positions of different obstacles ahead of him, just because he cannot see. Thank you.